Hi everyone. In this video I am going to start the fabrication process of CMOS. So CMOS, we know, complementary metal oxide semiconductor, which consists of both PMOS and as well as NMOS. So if you see the CMOS, it consists of both the PMOS in the pull up place and NMOS in the pull down place. That means PMOS transistor should be connected between VDD and output, and NMOS transistor should be connected between output and the ground. So that means we need both the transistors, and if these two are connected in such a way like between VDD and ground, then a CMOS can be constructed. So CMOS is basically not a transistor, it is a combination of two transistors like a PMOS and NMOS transistors. So in order to fabricate a CMOS on a single silicon wafer, we need to create both the PMOS and as well as NMOS on the single silicon wafer. So that by the application of voltages VDD and VSS, the CMOS structure is going to be created. So we are taking both transistors need to be created on a single silicon wafer. Okay, PMOS should be connected between VDD and output. NMOS transistor should be connected between output and ground. Okay, so there are three different methods that we can create this CMOS fabrication. So three methods are: CMOS can be created using three different methods. They are first one is N-well process or N-well fabrication process, and the second one is P-well fabrication process, and third one is twin tub process. So these are the three different fabrication methods available to create a CMOS device. Okay, that is N-well process, P-well process, and twin tub process or twin well process. Okay, which is a combination of both P-well and N-well. Okay, so in this video I am going to explain about N-well process, how the CMOS structure is going to be created using the N-well process. Okay, so N-well process. In the previous video, I have explained about the MOS transistor fabrication like PMOS and NMOS. Similar steps we will consider here like oxidation, diffusion, lithography, and chemical vapor deposition, metallization. All these techniques we will follow here also in the creation of CMOS. But along with that, we will create two well regions. Like in the N-well region, we will create N-well, and in the P-well process we will create P-well. Okay, that is only the difference. Additionally, we will be having few more steps, except that remaining all are same. So first, opposite is the case. Okay, for the creation of NMOS transistor, we will consider a P-type substrate. Here also for the creation of N-well, we will go for P-type substrate. So consider, first step, consider P substrate. Always we should go for the opposite case. Consider P substrate. So P-type substrate we are taking, which is a rectangular substrate like this. It is a P substrate. So we know the representation for the P substrate is like this cap representation. We should represent everywhere. So you can take it as first step. Second step is, what is the second step? Always the second step is creating the layer, top layer as insulator. So using the process using oxidation, create SiO2 on the surface of the substrate. Okay, so take the same substrate and now react the surface with the oxide layer, like nothing but we are passing the oxide O2 layer at high temperature on this surface of the substrate. Then as oxide is reacted with this substrate, silicon substrate, silicon dioxide is going to be created. So it is of 1 micrometer thickness. The thickness is 1 micrometer SiO2 layer. There are two different methods of this oxidation, thin oxidation, thick oxidation. Here we are using thick oxidation, which is of 1 micrometer. If it is 0.1 micrometer, that comes under thin oxidation. So oxide layer is represented by dots here. So we should represent dots, and this is the P substrate. Okay, so this is what the oxidation, using this oxidation we have created SiO2 layer. Now what we need to do, N-well we need to create on this P type substrate. So in order to create N-well in this particular area, we need to vacate the oxide layer from here to here. Okay, so remove the oxide layer in this particular part so that we can deposit, we can diffuse N-type impurities into this P-type substrate, so that N-well is going to be created. So how to remove the particular layer on the surface of the substrate? Using photolithography. That means again 3 steps are there. Applying UV rays. First one is depositing photoresist layer. Second one is applying UV rays, and third one is the etching. So in all together we will write using photolithography remove unwanted oxide layer. So what are the steps involved in that? First one is photoresist layer. So we are taking the same substrate. On this already we have 1 micrometer SiO2 layer. Now again this is the photoresist layer. This is the oxide layer which is already there, and it is the P-type substrate. Now the second one is apply UV rays. On this. So through a mask we are applying UV rays. So mask should be kept from here to here where we want to remove the oxide layer, because it makes the area soft so that we can remove. Now the last step is etching. Last step in this lithography is etching. Etching is nothing but removing the softer area. So now this is the layer we have on the substrate. Okay, now what we need to do, we need to deposit N-type impurities into this P substrate so that N-well is going to be created. So before that, let us vacate from here to here so that we can create a NMOS transistor in this P-type substrate. Okay, using the same process like photolithography, and we can vacate this particular place. So using photolithography, remove unwanted area. So here I am taking the direct step here. Okay, here also it consists of three steps: depositing photoresist layer, applying UV rays, and the last one is etching. So after etching, we will be having the structure like this. This is the oxide layer, this one is the oxide layer, this is the oxide layer. Now we have p-type substrate here. Okay, now diffuse n-type impurities, to create n-well, So we are taking the substrate. This place is for NMOS transistor, and this is the n-well region. This is the oxide. This is now n-well. N-well is nothing but just n-type impurities are diffused into the p-type substrate in large amount so that it creates some n-well region. Okay. Now again deposit thin oxidation. So using oxidation create 0.1 micrometer SiO2 on the surface. So now this is the n-well. So thin oxide has to be deposited on the entire surface. It is the P substrate and this is the n-well. Okay. Now what we need to do, so in order to create NMOS transistor here on the left hand side and PMOS transistor on the right hand side, we need to have this 0.1 micrometer only at the center, and before that we have to deposit polysilicon layer using the process called chemical vapor deposition. So using CVD, like a chemical vapor deposition, create polysilicon or deposit polysilicon at the gate. So as we are having two transistors here, it is NMOS transistor on the left hand side and PMOS transistor on the right hand side. So two gates are going to be created. So take the same structure. After undergoing a chemical vapor deposition technique, we will be having this gate terminal. So here one polysilicon layer, here another polysilicon layer, indication is black slash. So this is the chemical vapor deposition technique. Using chemical vapor deposition technique, the polysilicon is going to be created. Okay. Now remove this particular area and this one. Totally we need to remove 4 areas so that 2 p plus and 2 n plus regions are going to be diffused. Using photolithography, remove unwanted areas. Process is same, but here we are using for it for multiple times. So it is N-well region and it is p-type substrate. Okay, now here we need to diffuse to N regions and here we need to diffuse to P plus regions, so that NMOS transistor and PMOS transistors are going to be created. So using P plus positive mask, diffuse P impurities into the substrate. So here there are totally 4 different masks available: P plus positive mask, P plus negative mask, N plus positive mask, N plus negative mask. So P plus positive mask is for P-type diffusion. P plus negative mask is for N-type diffusion. N plus positive mask is for N-type diffusion and N plus negative mask is for P-type diffusion. Hope you understand. There are totally 4 different masks available. Suppose if you are taking P plus positive mask and P plus negative mask, then P-type and N-type atoms or impurities going to be created. If you are going for P-type diffusion with P plus positive mask, then go for N-type diffusion with P plus negative mask only. Okay, that means this set should be followed. Again, if you are creating N-type region using N plus positive mask, then use N plus negative mask for the P-type diffusion. This is another set. So what I am saying now, use P plus positive mask, then this set I have considered first set for the creation of P-type impurities. Then another mask should be P plus negative mask for the creation of N-type impurities. Okay, either of these you can use. Okay, so I am taking the same structure here. This is P-type substrate and N-well. Now what we are doing, P plus positive mask for P, where we are going to diffuse the P here. So this remaining area, entire area must be masked, and this is also masked. Now P plus, using P plus positive mask, this is P plus positive mask. Using this P plus positive mask, we are diffusing P plus atoms into this. Okay, so next, using P plus negative mask, create N-type diffusion. Okay, so here is the mask from here to here. As already we have created P plus diffusion. Here it is a diffusion area. Here it is a diffusion area. Okay, this is P-type in N-well region. Now in this step we are diffusing N plus regions. So it is N plus region, it is another N plus region. Okay, it is a P-type substrate. Okay, next one, what is the next step? Once the P-type and N-type connections are ready, next one is metallization. So before going to the metallization, in this CMOS structure, in this CMOS structure, we cannot directly go for the metallization with this N plus and P plus here. See, if you go to the P type and N type connections here in the CMOS, see the circuit diagram of the CMOS device. It is the input, it is the output, PMOS, and this is NMOS. Okay, so PMOS device is connected between, that means this is the source terminal and it is the drain terminal. This is the drain terminal of this NMOS transistor and this is the source terminal of the PMOS transistor. That means both the drains are connected to the output and the source of the NMOS transistor is connected to ground. Source of the PMOS transistor is connected to VDD. Additionally, for this NMOS and PMOS transistors, the hidden terminal is there, which is nothing but substrate. That substrate terminal we have not shown anywhere, but when you are working with the tool, definitely the substrate terminal should be connected to the source. Substrate and source should be connected together here and here. Source and substrate should be connected together. So as the substrate of these terminals will not come outside, we should diffuse that substrate material also beside this N plus region. Suppose if you take this, see what is this structure? This structure is nothing but NMOS transistor. What is this structure? This structure is nothing but PMOS transistor. So if you look at this NMOS structure, the substrate for this one is P-type substrate. So we need to create one P-type substrate beside this N plus region so that source and substrate connected together. And for this PMOS transistor, the substrate is N-well region. This N-well need to be created here so that the source and substrate can be connected together. So develop that P plus and N plus regions beside this N plus and P plus region which I have already created to connect the source and substrate together. Okay, so I will draw in the next step so that you can understand. So create P plus region in P substrate, N plus region in N substrate or N well. Well is nothing but substrate here for the source substrate connections. Okay. So here this is the P substrate. So already we have N region here. Now it should be P plus. Here we have N region. This is the N well region. N well where we have PMOS transistor. So this one is N plus region and it is P type. It is P type. Here it is the gate. Okay. So now the complete CMOS structure is ready now. So what else we need to do? Now we need to give metallization and then output connections. Okay, metallization, after that creating the contact cuts, later extending the contact wire like a copper or aluminum wire so that the source, drain and gate terminals are going to be created. Okay, I will write the statement and draw the final structure. See here. So using metallization, create contacts and extend for terminals. This is N-well region and it is the p-type substrate. Okay. So here it is the metal and polysilicon. At this terminal we have gate. Here we have metal. Here also we have metal. So remaining area is completely covered by the oxide layer. This is the one terminal. This is another terminal. This is the gate. Here we have drain and gate terminal. This is the source terminal and this one is the substrate terminal. See, this is substrate and this one is source. Connect these two together. And again this is substrate and this is source. Connect these two together. Take these two N and P regions as drains. So connect these two together as these two are connected to the output. And both the gates of this CMOS, both the gates of NMOS and PMOS transistors are given to the input V in. And see here, what is the circuit diagram of this CMOS? P-type. See, this is the input, this is the output. Now PMOS transistor is connected between VDD and output. NMOS transistor is connected between output and ground. Which is PMOS and which is NMOS? Which is having opposite substrate is nothing but the transistor. Suppose if you are taking PMOS transistor, N-type substrate is there. See, this is PMOS transistor. As N-well is the substrate here, this one is the PMOS transistor. And as P-type substrate is there, this one is the NMOS transistor. So NMOS transistor should be connected between output and ground. So that's why this substrate should be connected to VSS or ground. This substrate is connected to VDD. This is the final structure of the CMOS device using this N-well process. This is the indication. Okay. In the next video, I will explain about P-well process. Thank you.